Okay, here we go. 6-7, radical equations and inequalities. Today, in my opinion, is actually easier than all the other stuff we've done because it's just solving for x, which we've done for forever. The only way Algebra 2 makes it harder is they throw in weird symbols, okay? So if I gave you this question, don't write this down, just watch, okay? If I gave you that, what would we do? Add the 1, divide by 2, right? Done, 2 seconds, okay? The way that they make it harder is they'll shove like a square on it, okay? Well, wouldn't we add the 1 divided by 2 and then square root it? Or they'll add a square root sign or something like that. The idea is still the same is what I'm saying. So typically in Algebra 2, the first 1 or 2 steps are new for you, and I kind of lead you through them, and everything else is super old, super easy, okay? So I'm going to go through the list of what to do, but I also, some of you are memorizers, and that's great, and that works for you. Some of you aren't, and you actually want to understand what we're doing and why we're doing it. So I'm going to try to do both, but I'm also going to go fast because of our schedule today, right? So solving radical equations. All we're talking about today is radical, okay? So square root, cubed root, fourth root, something like that. So you can't really work with the radical sign. You have to get rid of it, okay? So step 1, isolate or get it alone, right? Get the root alone on one side of the equation if possible. Sometimes that's not possible, okay? Step 2, get rid of it. So if I have a square root, I'm going to square both sides. If I have a cubed root, I'm going to cube both sides. Do you see what I'm saying? So that's what this says. Raise each side to the power equal to the index of the radicand. So what that means is if I have a square root, square it. That's what that says, okay? And then you solve it like normal because it should look kind of pretty by then. It should look like this without the square root sign, okay? And then here's the step that you have to do, not an option. Check for extraneous solutions, solutions that do not satisfy original equation. Whenever you take both sides to the second power or to the third power, whatever, you could have created an extraneous solution, which means you did nothing wrong, but you created an extra answer, and we have to check for those. Does that make sense? Okay. And then I'll go to these in a second. We'll do the front side first, and then we'll go to the back side in a minute. Okay? So, this first question, number 23. I wrote them all on their own page so you have more space. I cannot say, oh, let's subtract 5. I can't do that. It's not really a 5. What is it? It's the square root of stuff, right? So I can't really work with that yet. So your goal every time is to get x alone. Some of you do PEMDAS backwards, and some of you say do whatever's farthest away from x first. The x is kind of attached to the square root sign. So I need to get rid of that as soon as I can. But I need to get rid of the other stuff first. Do whatever's farthest away first. So what's farthest away from the x? The minus 4. How do I undo a minus 4? Add 4. Yeah, and what you do to one side, you do to the other side, right? You don't have to show me plus 4 on both sides, by the way, unless that's helpful to you, okay? In Algebra 2, a lot of times you can just write down the answer. That's fine. So square root of 2x plus 5 equals 7. Is everybody okay with that? All right? X isn't alone, obviously, but I can't subtract 5 and divide by 2 because the square root is in my way. How do I get rid of a square root? Square, right? I square both sides because what you do to one side you have to do to the other. You have to keep it balanced, right? And a square and a square root cancel. They eliminate. So I'm left with 2x plus 5 is equal to 49. And I should be able to hand that to a pre-algebra kid and they'd get it right. Do you know what I mean? So that's your goal in Algebra 2 every time. The first step or two are a little bit hard, but after that you're like, oh yeah, easy, I'm good. Okay? Before you actually finish solving it, listen for just 2 seconds. I don't want to just tell you, oh, square both sides because that makes it go away. I want you to actually understand it. So I'm not going to use this number. Don't write it down. Just watch me for a second, okay? I'm going to do the square root of 3, and I'm going to square it. So that's the square root of 9, which is 3. Whenever you square a square root, they really do just cancel. Do you see that now? Okay? So I didn't want to show you with the 2x plus 5 because it's a little bit harder, but I want you to believe that that is really true. Okay? So now, go ahead and solve for x if you haven't already. Get x alone. And what is it? 22. Anybody need me to do the math to get you there? Are you good? Okay. So we have to check it, not an option. It's a good idea to check your answers anytime you can, but here you have to, okay? I'm going to tell you, you don't have to show me that you did. Some people like to write it down so they don't get it wrong. Some people can look at this and do it in their head. Because it's the first one, I'm going to go ahead and write it down and show you what we are doing, but if you ever just want to punch it into your calculator, you totally can, as long as you're getting it right, okay? So I'm going to check it. Whenever I check it, I always write the word check so I don't get confused as to what it is I'm doing. Kate. Okay, so 2x plus 5 minus 4, is it equal to 3? That's what I'm checking. Okay, so what is order of operations, PEMDAS or GEMS, right? Grouping symbols come first, so I have to do this first. So that's going to be 2 times 22 is 44 plus 5, 49, square root 7. What is 7 minus 4? Does 3 equal 3? Is that true? So then I feel like, okay, I can go ahead and circle the answer of x equals 22 because it is true. But do you see what I'm saying? I wouldn't mark it wrong if you didn't show me that. If you're someone who can just punch that in and not show it to me, that's okay. Eventually they get a little bit hard and I would probably write it down, but don't feel like you have to. Okay? Anybody confused? All right. Let's do 37 next. I think that's the next easiest one. Let's try that one. Okay? With this one, sometimes I think fraction exponents are easier, and sometimes I think they're a little bit harder. So on this question, I feel like it's easier to write it as a root. So can you guys rewrite this? What would go here? The 3, right? And then the 5p minus 7 plus 3 equals 5. So this is really the cubed root of 5p minus 7 plus 3 equal to 5. You could keep it as the exponent of 1/3. If you prefer that method, let me know later, and I'll show you that if we have time at the end. Okay? But either way, it's the same thing. All right? We have to get p alone. P is inside of a cubed root, so I'll deal with that later. What do I have to do first? Subtract the 3, right? So I have cubed root of 5p minus 7, and then 5 minus that 3 that we subtracted. If you like showing that, fine. If you don't, at this stage, you don't have to. And what do you get? 5 minus 3 is what I'm asking you. 2, right? Is everybody okay to this step? So P is kind of like in jail. P is in the cubed root jail, right? We have to bust him out. We can't deal with it the way it is. How do I get rid of the cubed root guy? Cube it. Yeah, you take this to the 3rd power, and what you do to one side, you have to do to the other, right? The reason we did that was so they would cancel. So 5p minus 7 is 2 cubed is 8. Good. From here, everybody can get p, right? So you add the 7, you divide by 5, and p is what? 3. I don't circle it until I've checked it. That's kind of my indicator to myself. Whoopsie, it's not really the answer yet. I'm not quite sure. Does that make sense? Okay. So I'm just going to plug it in. I'm not going to write it down this time, but you totally can. All right. So if I plug 3 in, order of operations says PEMDAS, parentheses, come first, right? So what's 3 times 5? 15 minus 7, 8, to the 1/3 power or cubed root of 8, which you should know by now. It's 2, right? Plus the 3, 5 is 5. I like to kind of like put a check mark there so I know that I did check it. You could just plug it in into your calculator and use the 1/3 power if you want to. It's up to you. So I now feel like, okay, I can circle it. I checked it. It's right. Mm-hmm.
If you plugged into the one where you changed it to a root, would that still work?
It would still work. Yep, either way. Mm-hmm. Anybody confused? Okay, great. Let's go ahead and do this one. Okay, we're going to skip number 45 because it's the exact same as 37. Do you guys see that? So we're not even going to do that one at all, okay? So if you need more room, you could write on that one. So on this one, again, your goal is to get whatever root alone. I don't really have a choice here. Yeah, this one's alone, but this one's not, right? So that 3's in the way. Well, if I move the 3 over, it's in his way. Does that make sense to you? Either way, the 3's in somebody's way. So I don't have a choice. I just have to square the way that it is. Do you guys get the difference between this one and that one, where on that one I was able to get alone, on this one I can't? The 3's in the way, okay? So if it's a square root we have to square, right? What do I end up with on the left side? X minus 15, because this whole thing was square rooted, so it went away. On this side, it is not 9 minus x. That's not what it is, okay? You have to write it twice and FOIL. People keep forgetting that. That's like the most common mistake the whole year. Do you guys get what I'm saying? It's not a shortcut to just square these two pieces. It doesn't work that way, okay? So there is a shortcut now, which, like I told you, from now on in Algebra 2, I'm always going to do the shortcut. If you know that that doesn't work for you ever, that's fine. Go ahead and start foiling without me and catch up in a second, okay? So I'm going to do the shortcut. Whenever you have the same thing twice, like this, a binomial times itself, all right, the shortcut is first thing squared, so 9. Last thing squared, so what's that going to be? Just an x, because two negatives make a positive, so it's going to be a plus x. And then the middle is times each other times 2. So 3 root x and another 3 root x is 6 root x. And it's a negative because they were negative. If you took your time and FOILed it out, you would get that. You'd get 9 minus 3 root x minus 3 root x, which is minus 6 root x, plus square root of x, which is x. Do you see what I'm saying? So it's a shortcut. If you get it, great. If you don't, FOIL. Either way, all right? So our goal now is to get x on one side and a number on the other side. So where do you want to start? There's like 5 different places you could start. It doesn't matter. Pick something.
Start on the right side.
Okay, with what? The 9, the 6 root x, the x? What do you want? Pick something. The 9? Cool. So if I want to start with the 9, that means I want to bring it over to his buddy, right? How am I going to move the 9 over? Subtract it, right? So it's negative 15 and negative 9. Negative 24. And we're left with this. Is everybody comfortable with that? You could have added 15. You could have subtracted x. Could have subtracted 9. I probably wouldn't have messed with that guy. Could have subtracted. Do you see what I'm saying? You could have done whatever you wanted, really. Okay? So now let's deal with the x, right? Not the square root of x. He's last. Always. Okay? So I'm going to subtract x from both sides, which really just goes away, doesn't it? It cancels out. X minus x is 0. Is that okay? So I'm left with negative 24 equals negative 6 square root of x. Again, the longer you do a problem, the easier it should look. What should we do now? Not yet, because the 6 doesn't have a square root sign. You divide by the negative 6, gone, right? And we get 4, right? So that I'm glad you said that, actually. So Caitlin had said, square it here. The reason you don't want to do that is because this guy doesn't have a square root, so he doesn't need it yet. You want to get the square root alone, and then you square. So that's what we do now, right? I'm going to square this side, gone, and I have to square that side. So x is 16 is what I ended up with. Does that make sense to you guys? Okay. What do we have to do? Check it. Have to, not an option, okay? I don't circle it till I've checked it. So I'm going to just plug it into my original before I started touching it with the red, okay? So 16 minus 15 is 1 square rooted. 1. So I'm going to write that down because that's too much for me to think about. This left side gave me a 1, okay? We said square root of 16 again. What's the square root of 16? 4. 3 minus 4 is negative 1. Do they equal each other? They do not. So the one answer we got didn't work. So my answer would be no solution. Does anybody need me to go back and say any of that again? So we did nothing wrong. You did it with me. Of course you did it right, right? We did nothing wrong, but our answer didn't work. It was an extraneous solution. So because the one answer we got didn't work, it's no solution. Sometimes you could end up with like 2 answers. In general, I'm just thinking, in general, you could have 2 answers. Maybe one worked, maybe one didn't. So you would circle the one that did, right? Maybe both didn't work. No solution. Maybe both did work. Circle both. Does that make sense to you? I don't think it gets that hard today, but I just want you to know that that could still be true. Okay? Okay, so before we actually go to the backside, let's read about it. So the backside is going to be all inequalities. So obviously the idea is still the same. You still want to get the root alone. You still want to undo it, all that good stuff. But if the index of the root, index is this number here, right? If the index of the root is even, find the values of the variable for which the radicand is non-negative. I'll put that in English on the back in a second. Solve it and test it. So again, there's really nothing new. It's just some extra information. So 51 is where I am. Okay. So for just 2 seconds, pretend it's an equal sign. What would we do? Add the 6 and then square it and then subtract the 14 and then divide by 2, right? So it's the same thing. I've said nothing new. I'm going to go ahead and keep the inequality though because sometimes it's helpful and sometimes it's not. So go ahead and do all this math with me, okay? I don't know what answer we get, but we said out loud what to do. So you add the 6, so we get square root of 2x plus 14 equals, greater than or equal to, I already forgot, 10. Square both sides, right? So 2x plus 14 equals what now? 100. And then what did we say? Subtract the 14. So 2x is equal to, oops, gosh, dang it. It's greater than or equal to. If you write an equal to sign, it's going to fix itself later, but either way, it's fine. Greater than or equal to what? What's 100 minus 14? 86. Divide by the 2, so x is greater than or equal to 43. Oops, 43. Well, pretend that says 43. So if this had been an equal sign, we'd be done other than checking it, right? Okay. So we've done this before where we had some answers and we had to put it on a number line and check for restrictions, kind of a thing. This is even, right? Because it's a 2. So we have to say what's not allowed to happen. What's not allowed to happen under an even root? Say it again. That's a denominator, I think, is what you're saying. What can't happen? Negative under the root, right? I mean, it can, it gives you an I, but it can't happen when we're doing stuff like this, okay? So I can't have under the root be a negative. So I have to say, hey, under the root can't be negative, which means greater than or equal to 0. Doesn't that mean I can't be negative? I can be 0 or higher, but I can't be a negative number. X can be negative, but the answer under the root cannot be. Do you get the difference there? Okay? So let's go ahead and solve that. What do? Subtract the 14, divide by 2, and we get x is greater than or equal to negative 7. Yes, that's true. Okay. There's a million different ways to do these, but I always teach you the one way that works every time. We can kind of think this through and get to the answer quicker than what I'm going to tell you right now, but for the sake of time and because it's the first day, I'm just going to show you what always works, okay? You put the answers you got on a number line. That's why the inequalities are kind of helpful but kind of not, okay? So negative 7 goes on here, 43 goes on here, and we have to check them like we've done before. Does that make sense? Okay. Can you see, guys? Do you need me to go down? Okay. So I'm going to go ahead and write the original equation again. It was square root of 2x plus 14 minus the 6 greater than or equal to 4. So this is the original. So I'm going to check, like, what do you guys want to check over here? Why do I have negative 4? That's weird. Sure, yeah, negative 10. Sorry, I'm looking at my old stuff. And then, like, let's do 0 maybe. And then, I don't know, what do you want to do? You can do 44 or 45 or 100, or you can do whatever you want, right? So let's just do like 44, okay? I want everybody to check 0 with me. Let's start with 0 because that's typically the easiest, okay? If I put 0 in the original function, okay, 0 times 2 is 0 plus 14, I don't know what the square root of 14 is. Can you guys do that? What's square root of 14? Say it again. 0.74. So 0.74 minus 6 is a negative number. I don't care what it is. It's negative. It's not bigger than 4. Does that make sense to you? So that did not work. So big ol' X. Okay? So let's try negative 10. Negative 10 times 2 is negative 20, right? Plus 14 is negative 6. I can't even do a square root of a negative for today's purposes, so no, right? I hope this one's yes, but maybe it's not. I don't know. We'll have to check it. So let's plug 44 in. Take 44 times 2, 88, plus the 14. What is it? I don't know. 102, yeah. Square rooted is the part I didn't know is what I meant. Just round for me. What is it? 10 point something, right? So 10.1 minus 6 is 4.1 whatever. So it worked. Check mark. Does that make sense to you? So the only answer that worked was the greater than or equal to the 43. So if you think about it, these are the answers we're doing. We're just checking in between them. So 44 is not my answer. 44 helped me check it, okay? So the only answer that worked was this one. And we have to go back and remember this is how we write it because we're fancy. We're Algebra 2 students now, right? So 43 including, so bracket, and then infinity, so parentheses. If you've forgotten how to do interval notation, I'm happy to help you, just not right now, right? I think I have a video on it, by the way, if that's helpful to you. If not, you can come see me later and I'll help you with interval notation stuff. Do you at least understand that this was our answer? Everything else didn't work? Okay? Anyone still need it? All right, great. How much time do I have? When do we? It's 40, 20. This one is the exact same thing. So let me show you what's going to happen really quickly if you're okay with that. Okay? We're going to get y is less than or equal to 2. At least write this down. I don't think you need my help getting there. Okay? We would get y is less than or equal to 2 if we just solve it. This is an even, so we have to do this extra part. Remember? And here we would get greater than or equal to negative 5 halves. So these are the ones that would be on our number line. Okay? I know I didn't actually do the math, but I feel like you guys are okay, right? So we would check here, here, and here. Again, I'm going to save you time. I'm going to let you know that this one's an X, this one's a check, and this one's an X. So the middle would work. You guys get I'm not actually doing any math, right? Okay. So I want to just kind of help you remember how to write the interval notation because I think that's the hard part for you. You always go left to right, smaller to larger, either way. So I know it's in between negative 5 halves and 2. And because it has the straight, sharp line, they're both going to have the straight, sharp line, the brackets. That's how I remember it, if that helps you. So that would be our final answer here, even though we didn't actually do anything. Okay? Because this last one's a little bit tricky, I feel like. Is that kind of okay? It's the exact same thing as the last one, but the answer looks different. And we only had to check it because this is an even. If this had been a cubed root, we wouldn't have to check it. We just would have kept this answer and written it in interval notation. It's only with the even ones that you have to check. All right? So at the top of your notes, where you are right now on the back page, I want you to make a note because I think it's hard to understand. I want you to write at the top, if even root with an inequality set under the root greater than or equal to 0. I'll say it out loud because it's hard to read. If it's an even root with an inequality, not an equal sign, set under the root, whatever's under the root, write down, greater than or equal to 0. And that's what we said on the front, and that's what we did, but sometimes I think when we kind of put it in English, it's a little bit easier to understand. Is that kind of okay? So take whatever's under the root, write it down, greater than or equal to 0. And that's your possible restriction on it. Okay? Last one. This one is just like the front, where no matter what you do, the square root's not going to be alone. If I move this over, it's still not alone. If I move this over, do you see what I'm saying? It's never alone. So let's just go ahead and square what we have. Okay? For the purpose of what we're doing right now, you can kind of ignore the inequality. It's not really that helpful till the end. I don't write an equal sign down because then I forget to do the number line check, but you don't have to like freak out about the inequality yet, okay? So we'll do this part in a second. It's going to be greater than what? Just a 3, right? Okay. There is a shortcut, but not yet. It's not going to be just this minus that. It doesn't work that way. It's a binomial, so I have to write it twice. And FOIL, which isn't as scary as it looks, I promise. Okay? I don't want to FOIL that. I know a shortcut, and it's super helpful to me. All right? The shortcut is, you guys are still writing. Am I going too fast? Are you okay? Okay. The shortcut is, it's the same thing twice. So I'm going to take the first piece and square it. What do I get when I square that? Just C plus 9, right? So that part's taken care of, right? I like to jump to the last part because it's the same rule. I'm going to take the last piece and square it. Well, 2 negatives make a positive, right? So it's going to be a C. And then the middle is whatever this sign is, times each other times 2. Okay? So for right now, I'm out of room. I'm going to write C plus 9. Times each other times 2 would be minus 2. I'll just write it like this for right now. Do you understand that it would be times each other times 2? I'll shove them together in a minute. That's the shortcut. If you still don't get the shortcut, you need to see me later, okay? Whenever they're both under a square root sign, can't I shove them together? Right? So that'd be C squared plus 9C under the square root sign, if you use your distributive property, okay? So I've got C plus 9 minus 2, C squared plus 9C, plus that extra C at the back. Okay, so that's going to be 2C, right? Plus the 9 minus 2, the C squared plus 9C greater than the 3 for right now. I wrote myself a note. Oh, yeah, I see it. I see it now. Yeah, I think we're good. I haven't done anything crazy. I know it looks scary. I know that. But I don't think I've done anything where you're like, I don't understand what I just did. Am I right? How can I make this look a little bit prettier? What can we do here? Did I lose you?
Subtract the 9.
Yeah, let's subtract the 9. So I have 2C minus the 2C squared plus 9C guy. Greater than what's 3 minus 9? Negative 6, right? So from here, hold on, I'm going to pause for just 2 seconds. What we're doing is not wrong, but I wrote a note to myself that there was an easier way, so let me see if we're there yet. Hold on just a second. What did I do? I squared it, but I don't think I want to do that. What did I do? 2C plus 6, and then I moved that over. I'm trying to think of the easier way. It's okay. What we're doing is fine. We'll just keep going. It's okay. Let's go ahead and get the square root alone. Okay? So I'm going to add the 6 here, and I'm going to move this over. Do you get that you have like a million options? That's just what I'm going to do. Okay? So 2C plus 6 is greater than 2 root C squared plus 9C. Okay? So here's what I'm going to do. I'm going to divide everything by a 2, and it's going to be way less nasty. Do you guys get that? You don't have to do it this way, but this is really 2C plus 3, right? And this is still our 2 whatever. Are you with me there that that's the same? Okay. You didn't have to do it this way, but if you don't, I think you guys don't understand pulling out the 2 is the same. So I'm going to divide everything by a 2. Was that okay? So I'm left with C plus 3 greater than square root of C squared plus 9C. And here's where it gets easier, in my opinion. Do you see that I could do that? That way it just didn't look as nasty. I couldn't have squared both sides yet because that 2 was in the way anyway. So I had to get rid of it. But when I write it this way, you guys don't forget that that was really a 3. But when you leave it this way, some of you forget to divide that by a 2. That's why I pulled the 2 out. So from here, it looks like all the other problems we've had. What do I do now? Square both sides and blah, blah, blah. Everything's the same, okay? Square square. Getting there was a little bit harder on this one, but once we get there, it should be easy. What's the left side going to give me? You FOIL, but you should be able to do the shortcut even from here now. So it's first thing squared, right? Last thing squared is 9 times each other times 2. 6c. If you have to write it twice to let yourself know that it's not c squared plus 9, you can. That's fine, but I'm not going to. And it's greater than what? C squared plus 9c. Now what? C squareds cancel. Very good. 6c plus 9c greater than, oops, why did I write a c again? Sorry. 6c plus 9 greater than 9c. So now what? I subtract the 6c, yeah? So 9 greater than 3c. So now what? Divide by the 3. So 3 is greater than c. Whew. Or some of you prefer either. That's the same answer. We're not done. It's an inequality. Right? It's an inequality with evens. So I have to do my extra special check. Okay? So c plus 9 has to be greater than or equal to 0, and c has to be greater than or equal to 0. So I've got this guy, I've got this guy, and I've got this guy. Okay? So that c is greater than or equal to negative 9. So those 3 are what I'm going to have to put on my number line. How much time do I have? 10 minutes. Okay, I'm going to pause here. I know this one's really hard to get to here. Okay, so let's just kind of go back through it just one more time. We squared it in the beginning. It wasn't pretty, but it was doable, right? You do your shortcut, and you get the square root as alone as you can, which is why we divided by the 2. And then this looked normal. This should be easy. Even if I lost you all up here, you should be good down here. Okay? So now we're here. The only reason we have to do the extra piece is because it was a square root, which means we can't have negatives under a square root, right? So I had to say the one square root was greater than or equal to 0, and the other one was greater than or equal to 0. I solved it, already solved. We already did that by ourselves. That makes sense? So we're going to do our number line. You go in order, right? It's a number line. So what would go on the left side? Negative 9, the 0, and the 3. We check here, 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 here. I'm going to assign rows, okay? Let's do like, I don't know, negative 10. Let's do maybe negative 1, 1, and 4. You know I'm totally just picking numbers, right? I don't know like anything more than you do, okay? So you plug it into the original equation. So this first row, you get the fun one. You get the negative, negative 10. So you're going to plug it into our original equation and see if it's true or false. The second row up to Janess, let's do negative 1. And then positive 1 is just you two in the back. And then the girl row is the 4. Everybody has their own job, right? So plug it into the original black function in mine, right? Okay? And see if it's true or false. Ask the people around you if they agree with you, right? And if it's hard for you, ask me a question. I would definitely use a calculator. For the sake of the video and you guys working on it, I'm going to plug in 1, just so you can make sure you're doing it right, okay? That would be 1 plus 9, which is 10, square rooted. I don't know what that is. So square root of 10 is 3.16, so I'm going to leave it in my calculator. So this is like 3.16 minus square root of 1 is 1. So I get like 2.16 something, right? I'm trying to see if it's greater than whatever the square root of 3 is, 1.73 something. So it looks like when I plugged 1 in, it was true. Do you guys get that? So this guy should work, okay? So try the other 3 if you haven't already. Do my negative 10 people think you have a true or false? What do you think it is? It didn't work. Yeah, it didn't work. So negative 10, was it too big? Is that why? I need to go all the way back up here. Yeah, negative 10 plus 9 is negative 1, so already false. Done. Does that make sense? What was the next one? Negative 1? Negative 1, did that one work? Do you guys know? It didn't. Nope, shouldn't. What about 4? No. So we only got this piece to work, right? So if we had been back in an old section, the 0 would have been a closed circle and true, right? And the 3 would have been an open circle and true. Is that kind of coming back to you, that part? You always go smaller to larger, so it's going to be 0, 3. What's the 0 get? Parentheses or bracket? Bracket. What's the 3 get? Oop, I was going to write you 3 again. Yeah, parentheses. That is your final I'm done answer. Okay, the last question is always the hardest. Were you pretty okay with me in life before the last question? Okay, great. The last question is always a bit harder. I'm not going to give you 50 of those on a test, right? Okay, so